In today's digital age, our lives are intricately intertwined with the online world. From online banking to social media, we rely on web servers to access a plethora of services. However, this reliance also makes us vulnerable to cyber attacks that can disrupt these essential services. One such attack that poses a significant threat is the denial of service or DDoS attack. A DDoS attack is a malicious attempt to make a server or network resource unavailable to legitimate users. Imagine a busy shop suddenly being flooded with a huge crowd, making it impossible for genuine customers to enter or make purchases. Similarly, a DDoS attack overwhelms a server with a barrage of traffic, rendering it incapable of responding to genuine requests. Denial of service attacks can take various forms, ranging from simple ping floods to more sophisticated application layer attacks. The goal, however, remains the same: to disrupt the target's operations and deny service to legitimate users. While a DDoS attack originates from a single source, a distributed denial of service, or DDoS attack, involves multiple compromised systems, often forming a botnet. These botnets act like a coordinated army, flooding the target with an overwhelming volume of traffic, making it even more challenging to mitigate the attack. DDoS attacks come in various flavors, each exploiting different vulnerabilities to achieve their goal of service disruption. Understanding these different types is crucial for implementing effective countermeasures. One common type is the SYN flood attack, which exploits the TCP handshake process. When a client wants to establish a connection with a server, it sends a SYN or synchronization packet. The server responds with a SYNAC or synchronization acknowledgement packet, and the client finalizes the connection with an ACK or acknowledgement packet. In a SYN flood attack, the attacker sends a massive number of SYN packets to the server, but never completes the handshake by sending the final ACK packet. This overwhelms the server's resources as it tries to keep track of these half-open connections, eventually making it unresponsive to legitimate requests. Another type is the UDP flood attack, which targets services that use the User Datagram Protocol, or UDP. Unlike TCP, UDP is a connectionless protocol, meaning there is no formal handshake process. Attackers exploit this by flooding the server with UDP packets, overwhelming its ability to process them. The impact of DDoS and DDoS attacks can be devastating for businesses and organizations. Websites can become inaccessible, leading to loss of revenue, damaged reputation, and frustrated customers. In extreme cases, these attacks can disrupt critical infrastructure like power grids and financial institutions, causing widespread chaos. In the realm of cybersecurity, ethical hackers play a crucial role in identifying vulnerabilities before malicious actors can exploit them. These cybersecurity professionals use a variety of tools and techniques to simulate real-world attacks and assess the security posture of systems and networks. One such tool that has become synonymous with ethical hacking is Kali Linux. Developed by Offensive Security, Kali Linux is a Debian-based operating system specifically designed for penetration testing and security auditing. It comes pre-installed with a vast array of tools, making it an indispensable asset for security professionals. Kali Linux provides a controlled environment for ethical hackers to conduct security assessments without risking damage to production systems. Its intuitive interface and comprehensive documentation make it accessible to both beginners and seasoned professionals. Among the plethora of tools available in Kali Linux, some are specifically designed for conducting DDoS and DDoS attacks. These tools allow ethical hackers to simulate real-world attack scenarios and assess the resilience of their systems against such threats. However, it's crucial to emphasize that these tools should only be used for ethical and legal purposes. Within Kali Linux's arsenal of tools, HPing3 stands out as a versatile utility for network security testing. It's often referred to as the Swiss Army knife of network tools due to its ability to craft and send custom packets, making it valuable for various tasks, including DDoS attack simulation. Unlike basic ping utilities that only send ICMP echo requests, HPing3 can generate packets for various protocols, including TCP, UDP, and ICMP. This flexibility allows ethical hackers to test firewalls, bypass network address translation or NAT, and simulate different types of attacks. For DDoS attack simulation, HPing3 can be used to flood a target with a high volume of packets, overwhelming its resources and potentially causing a denial of service. For instance, it can send a barrage of SYN packets, exploiting the TCP handshake process as described earlier to simulate a SYN flood attack. While HPing3 is a powerful tool for security testing, it's essential to use it responsibly and ethically. Launching an actual DOS attack against a target without permission is illegal and can have severe consequences. Section 5. LOIC, unleashing the power of the crowd. While HPing3 provides a command line interface for crafting and sending custom packets, LOIC, or Low Orbit Ion Cannon, offers a more user-friendly approach to DOS testing, particularly for simulating DDoS attacks. LOIC is an open-source application that allows users to participate in distributed denial-of-service attacks. It works by flooding a target server with TCP, UDP, or HTTP requests, overwhelming its resources and potentially causing a denial of service. One of the key features of LOIC is its ease of use. Its simple interface allows even those with limited technical knowledge to participate in DDoS attacks. This accessibility has made LOIC a popular tool among hacktivist groups, who use it to target websites and online services they deem unfavorable. However, it's crucial to remember that participating in a DDoS attack, even using a tool like LOIC, is illegal and can have serious consequences. While LOIC itself is not illegal, using it to attack a target without permission is a crime in most jurisdictions. Section 6. DDoS attacks, a distributed menace. As mentioned earlier, DDoS attacks take DOS attacks to a whole new level by leveraging the power of multiple compromised systems, often forming a botnet. These botnets, consisting of hundreds, thousands, or even millions of compromised devices, act like a coordinated army, flooding the target with an overwhelming volume of traffic. The distributed nature of DDoS attacks makes them significantly more challenging to mitigate than DOS attacks originating from a single source. Blocking a single IP address is ineffective against a botnet, as the traffic originates from numerous sources. Botnets used in DDoS attacks are often created by infecting unsuspecting users' computers with malware that allows the attacker to control their devices remotely. These compromised devices, known as zombies, become part of the botnet without their owner's knowledge. The motivations behind DDoS attacks vary widely. Some attackers aim to disrupt businesses and cause financial losses, while others use them as a form of protest or to silence dissenting voices. Regardless of the motivation, DDoS attacks pose a significant threat to the availability and stability of online services. Section 7. GoldenEye and DDoSim, simulating DDoS attacks. Given the increasing sophistication and prevalence of DDoS attacks, it's more important than ever for security professionals to test their system's resilience against such threats. Kali Linux provides several tools specifically designed for simulating DDoS attacks, allowing ethical hackers to assess their defenses in a controlled environment. GoldenEye is one such tool that has gained popularity for its ability to simulate various DDoS attack scenarios. It allows users to customize the attack parameters, such as the number of bots, the attack duration, and the type of traffic to generate, providing a realistic simulation of a real-world DDoS attack. Another tool, DDoSim, focuses on simulating application-layer DDoS attacks. These attacks target specific applications or services running on a server, rather than the network infrastructure itself. DDoSim allows ethical hackers to test the resilience of their applications against various attack vectors, such as HTTP floods and slow LoRaWAN attacks. By using tools like GoldenEye and DDoSim, security professionals can gain valuable insights into their system's vulnerabilities and implement appropriate countermeasures to mitigate the risks posed by DDoS attacks. Section 8. Ethical hacking and legal implications. The tools and techniques discussed in this essay can be incredibly powerful in the hands of cybersecurity professionals. However, it's absolutely crucial to emphasize that these tools should only be used for ethical and legal purposes. Ethical hacking, also known as penetration testing, involves simulating real-world attacks to identify vulnerabilities in systems and networks. Ethical hackers operate with the permission of the system owners and adhere to a strict code of ethics. Using DOS or DDoS tools against a target without permission is illegal and can have severe consequences. Depending on the jurisdiction and the severity of the attack, penalties can range from hefty fines to imprisonment. It's essential for anyone interested in cybersecurity to understand the ethical and legal boundaries within which they must operate. Engaging in any form of unauthorized hacking activity is not only unethical, but also a criminal offense. Section 9. Conclusion. Staying ahead in the cybersecurity landscape. In today's interconnected world, DOS and DDoS attacks continue to pose a significant threat to businesses, organizations, and individuals alike. Understanding the mechanisms behind these attacks, the tools used to carry them out, and the ethical and legal implications is paramount for staying ahead in the ever-evolving cybersecurity landscape. Kali Linux, with its vast array of tools like HPing3, Loic, GoldenEye, and DDoSim, provides security professionals with the means to simulate real-world attack scenarios and assess the resilience of their systems. However, it's crucial to remember that these tools are double-edged swords. They can be used for both ethical hacking and malicious purposes. As technology advances, so too will the sophistication of cyber attacks. Staying informed about the latest threats, vulnerabilities, and mitigation techniques is an ongoing process. By embracing ethical hacking practices and adhering to legal and ethical guidelines, we can work towards a safer and more secure digital future.